Alright, starting lesson 10.3, solving radical equations. Alright, for example 1, solving radical equations, we have a radical in our equation, and we want to isolate that radical first, which has the variable. So I have square root of x equals 8. Alright, now if you had x squared here equals 8, you would take the square root of both sides to get rid of the square. Now how do you get rid of the square root? Well, you square both sides. Alright, when you square both sides, that essentially undoes the radical or square root and just leaves you with x. And then 8 squared is 64. Done. That's all there is to it. Alright, same thing for b. We subtract 3. I have negative square root of x equals negative 3. Then I divide by negative 1. And square root of x is equal to 3. Alright, so now I square both sides, and x is equal to 9. That's all there is to it. Very simple. Alright, going on example 2, solving a radical equation. Alright, first thing we have to do is isolate this whole radical. Alright, now how do we do that? First we subtract 3. We get 16. Then we divide by 4. Square root of x plus 2 equals 4. Alright, now that I have the square root by itself, I'm going to square both sides. And I'll get rid of the radical. Alright, so now I just subtract 2. And x equals 14. Done. That's all there is to it. Alright, next one. I have radicals on both sides of the equation. So what I'm going to do is I'm going to square both sides then to get rid of them. So I get 2x minus 1 equals x plus 4. Alright, now I'll add 1. So I have 2x is equal to x plus 5. And I'll subtract x. So I get x is equal to 5. Done. Alright, it goes really fast once you understand what you're doing. Alright, solving a radical equation involving a cube root. Okay, here's a cube root. So how do you think you undo a cube root? Well, you cube both sides. Alright, so now I have 5x minus 2. The radical disappears. And I have 12 cubed. So 12 times 12 times 12 is 1,728. Alright, then I'll add 2. I get 5x is equal to 1,730. Then I divide by 5. And x is equal to 346. Alright, that's all there is to that. On to the next problem. Okay, now a very important concept to be aware of is that whenever you are squaring each side of an equation, sometimes you introduce an extraneous solution. Alright? Extraneous solution means that you're solving an equation and you end up with what you think is a solution, but when you test it out, it ends up not to work. It's not true. So here's an example of that. And you should actually do this with all radical equations. We just didn't do it with the previous ones just so we can move through the process of isolating the x variable, but you should actually do that with any radical equation. Okay, so here we have a radical equation. We're going to have to square both sides. I get x squared is equal to x plus 6. Alright, then I'll subtract x. I get x squared minus x equals 6. And I'll subtract 6. I get x squared minus x minus 6. Alright, then I use the big X method. What two numbers add up to negative 1? Multiply to give me negative 6. That would be negative 3 and 2. So I end up with x minus 3 times x plus 2. And that's equal to 0. Alright, so I solve, and I get x is equal to 3, and I get x is equal to negative 2. Now, if I plug these in to the equation, alright, plug my solutions in, 3 is equal to square root of 3 plus 6. I get 3 is equal to the square root of 9, so 3 is equal to 3. That's true. Alright, but for the other one, I have negative 2 when I plug that in, is equal to the square root of negative 2 plus 6. I get negative 2 is equal to the square root of 4. Negative 2 does not equal 2. Okay, so that's false here. All right, negative 2 does not equal 2. And so negative 2 is not a solution to the problem. So x equals 3 is the only solution. All right, watch out for that. Test all your solutions whenever you're working with radical equations and you're introducing a square into the problem. All right, and last example. Here I first have to subtract 13. Square root of 5n is equal to negative 10. All right, and then I'm going to square both sides now to get rid of the radical. I have 5n is equal to 100. I divide by 5, and n is equal to 20. All right, now for the 20, if I plug it back in, I have 13 is equal to 5 times 20, which is equal to 3. Oh, sorry, this should say plus. So I have 13 plus square root of 100 is equal to 3. I have 13 plus 10 is equal to 3, so I get 23 is equal to 3. That's false. So there's actually no solution for this problem. All right, that's an extraneous solution. All right, that's all there is to it. Begin the assignment at the bottom of the webpage.